All right, welcome back. Today's topic, review of your grade 11 trig functions. So today, no homework associated with this particular section. The video is just a straight recall of some of the properties dealing with trig functions. You're going to need this information. You're going to be working with it as we work through the next couple of days anyway. So recall, grade 9, or sorry, grade 11. And I know for some of us, this is a painful experience, this recall, but we do need to remember what we talked about last year. So what is a periodic function? Okay, we talked about periodic functions last year. Very, very important that we remember what that is today. Periodic function is a function that repeats the same pattern over the same period. All right, so the keys there, it repeats itself, same pattern, same period. Now, some of you are going, well, what the heck does period mean? Already anticipated. Period is the time it takes for one cycle, and underneath you can put in brackets pattern, to occur in a periodic function. All right? So the sign graph. Last year you did a great investigation which led you to the general shape, and we did some other stuff with it. Here's the function y equals sine x. For those that don't remember, it is a function that repeats itself every 360 degrees. So along the x-axis, starting at 0, we're going to evenly space it out, 90, 180, 270, 360. Those are our x values. The y values, if you recall, you only have to go up for a base y equals sine x function. It stays between 1 and -1 on the y-axis. Now, some of you last year, actually, no one from this class is able no one from this year is going to sit there and tell me, well, I don't know whether it starts at 0 or what does it do, because you can punch this in the calculator. This is not secretive. It's not something you got to memorize. Punch into the calculator. What does y, or what does sine of 0 equal? Your calculator will tell you. It's 0. Punch in sine of 90 degrees. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. Sine of 360 is 0. There's your cyclic pattern. You just need to connect it now with the smooth curve. And there we go. There is your sine graph. All right. Some key characteristics while we're here. The distance from the x-axis down to what we call trough, or the distance from this is called a crest. So a crest or trough to the center line, that is known as our amplitude. Amplitude. Okay, so there's our amplitude, and I'm just going to go down here below from here all the way to here. That is the period. Okay, how long to repeat. All right, so those are two key words that we did learn about last year. So you do need to know what is amplitude. You do need to know what is the period. And I also expect you to understand trough and crest when they're referenced. Those are all key words from grade 11. All right. The coast graph, I'm not going to go into nearly the detail that I did on the first one. So the y values go from 1 to -1. Again, going up by 90s. So 90, 180, 270, 360, and that's the x. Again, you can plug this into your calculator. Calculator will tell you what the values are. Cos of 0 is 1. I guess I'll put the equation up here. Y equals cos x. Cos of 90 is 0. Cos of 180 is -1. Cos of 270 is 0. Cos of 360 is 1. Once you have your key points, you can connect nice smooth curve through all of them. It has amplitude because there's crests and troughs. It has a period where it starts again or repeats itself, so on and so forth. What I'm going to take the time to do here on this one, I'm going to draw the cast rule over here. And I know you're so excited. We've seen cast rule. And I always like keep coming back to it just to show you how it plays a role. So the cast rule. Cast rule tells you where things are positive and negative. So if I start at 0 and go to 90 degrees, and then we go to 180, then we go to 270, and when we get back, we're at 360. So here's something that's pretty cool. In the first section, 0 to 90, all trig functions are positive. All right? So that means that my y values in here, so my y values for cos are going to be positive. So look, y, that trig function, is above the y-axis for the first 0 to 90 degrees. When we get to the second quadrant, only sine is positive, which would mean the cos would have to have negative values. So from here to here, look at this. The cos graph has negative y values. In quadrant 3, only tan is positive. So from 180 to 270, that means cos would have to be negative. Hey, look at this. Negative values, negative y values in that quadrant. Last one, cos is positive in quadrant 4 from 270 to 360. Look at this, 270 to 360. It's above the y-axis. Pretty neat, eh? And if we take a step back, look at this. Sine is positive with the cast rule from 0 to 180. Look at that. It's above the x-axis. It has all positive values from 0 to 180. From 0 to 360, sine's negative. And look at this. Negative from 0 to 360. Pretty cool, eh? Cast rule ties in over and over and over again with trig. All right? So let's compare sine and cosine graph. So what's the same and what's different? So we're supposed to provide, when you're doing a compare question, compare means to provide an example. So an example, y equals cos x and y equals sine x. All right, actually we can do that up above. All right, so here's our example. Let's do it off to the side here. So example, y equals sine x, y equals cos x. Just easier that way. What's the same? I see hands up, which is great. Period. Period is the same. All right, period, and that's equal to 360 degrees. So it repeats itself every 360. All right, what else is the same? Perfect, another hand up. Amplitude. Amplitude is the same, and the amplitude in this case for a base function is 1. Hey, what's different? All right, good job. Starting point. All right, your starting point. So sine x starts at 0, starts at y equals 0. Cos x, y equals positive 1. And yeah, it looks the same. It looks like a phase shift has occurred. We're going to talk about that a little bit later on. So there you go. There are some of the similarities and there are some of the differences that we talked about last year in the grade 11 course. Like I said, there's no homework associated with this section. The only thing I want to finish with is basically all that's left is graphing. I've been trying to not use the G word because I know everyone's excitement for graphing is overwhelming. So splitting this down a little bit. What is the equation of a trig function? Well, last year we went through it, and you're going to see it again because we do need mastery of this skill. I put some extras in the 3M course. If you didn't have me in the grade 11 course, you're going to find some things new, but for the most part, everything was already included in one big package. So we're either going to have, and I'm just going to use the sign because and the variables might be different depending on the teacher you have. So this is the equation. That is a really weak looking Q. There we go. That's pretty nice. So y equals a sine kx minus p plus q. So I always tell people go back to their years of grade 10 when you did parabolas, grade 11 when you did parabolas. I know they were glorious times. And that's what I always go back to. So for example, your Q value, what does the Q value do for you? This is a vertical shift. And it's still a vertical shift when we talk about trig functions. What did the p-value do for you? What did the p-value do? Excellent. I like to see hands up and volunteers here. It's a horizontal shift. Horizontal. Almost forgot how to spell there for a second. Horizontal shift. Okay, so that's our horizontal shift. K value I'm going to talk about separately for a second here. I'm going to actually come back to it. And the A value, I'm just going to put straight down here. Now, most people are going to say, well, that's the vertical stretch or compression. And you're right, vertical stretch / compression. Now, the only difference is we don't really have we do stretch and compress. I don't want to say we don't really do it. What happens, though, when you stretch, say, the sine function? So the green one's going to be the original. And if I stretch or compress it, all you're really doing is changing the amplitude. Excuse me. So bottom line, amplitude is what your A value is. It's almost like we planned it. For those that are a little bit weaker in the English, A and amplitude starts with an A. See the connection? Okay. If you don't see the connection, I'll talk to you about it tomorrow. All right. So moving on to the last one, the K value. Some people talk about it, some people don't get to it, and that's fine in their grade 11 year. K is your, for those that did do it, it is the horizontal stretch or compression. All right. So what does that really mean for us in terms of the trig function? It is our period. All right. So our period is going to be based on whether it was a stretch or compression. So the formula, first of all, period, I use capital T to represent period. I don't know why. It's from physics. I just carry it over to the math. So period, T equals 360 divided by your period, and it is a capital P, not the little p. So let's not get this kind of messed up. Little p for phase shift, capital P is your period. All right, and we can rearrange it. And actually what I will do, let's change this right now. Let's get rid of T. Let's make it a K. Then it matches up with our equation. So the equation then, matching the K up from my equation up there, K equals 360 over P, and P is for period. All right, so I'll just put that in there. And we can rearrange that equation and go the other way, so that period is equal to 360 divided by your K value. So this is something that's going to make its way onto your cheat sheet, as will this probably. So you have all that information there when you go to do the graphing, and that's where we're heading in the final 2 units. So if you have any questions with this from last year, let me know, and we can go through and hit the points you don't know or don't remember. And then if not, you're more than welcome to head into the next lesson and we talk about going ahead and doing some graphing. Good luck.